Engineering is changing forever. If you're an engineer today, you stand on the edge of the biggest change in software since software began. This isn't a debate. It's going to change everywhere, full stop. If you write code for a living or are a leader, this message is for you. This is going to redefine what it means to be an engineer, and this is the shift. We will still need engineers. We will still need people that understand these systems. I am not the one here to tell you that all engineering goes away. In fact, all coding won't go away. We will have that for quite a while as we start transitioning different systems through this change. It will take time. Some systems will be very resistant to it for a while, but we are about to go into why that resistance is futile. No matter what, no matter how hard a system is to transfer, it will go through this transition for an actual reason. We'll cover that in just a second. Now, I've heard a lot, and I mean a lot of engineers that I've talked to that tried to use these tools in certain circumstances, didn't get back the responses that they wanted, and then they just kind of backed off and said, this stuff doesn't work, it doesn't fit, it's poor, it gives me back bad examples, it convolutes things, it makes changes I didn't ask for. I think everyone here has experienced these, and I am not here to tell you that that is wrong. That is actually true. However, that does not preclude the fact that it is still here and transitioning. We are actually going through this change. Even if today it's bumpy and maybe not great, we are still going to go through it. Listen, I understand enterprise code. It is very complicated. So anyone out there that works in an enterprise environment, I do agree with you. It is different at that scale. It is much more difficult. It's more painful. It's more expensive to imagine changing. And it's not necessarily a direct line to that change. It's kind of convoluted to figure out how you might apply a change that draws the 10 times, 20 times value that we're talking about out. But that doesn't protect anything. Just because it's difficult doesn't mean it won't change. And that's really important. The smaller companies, the startups, the independents out there, they'll be able to change and start gaining that efficiency immediately. If they have that efficiency and you don't have that efficiency, that will become starkly clear very, very quickly. So let's talk about this efficiency curve that I'm kind of hinting at. All right, let's talk about this thing I call the efficiency curve. This is our company. Everybody's working at 1 times efficiency. Effectively, that's actually today. What we put out is how much we can put out. We hear about this AI thing, so we decide to put in a change. We heard, hey, we can flip a switch. AI makes us all 10 times efficient. That's great. Here we go. Our productivity is 10 times. Obviously, there's a whole bunch of ridiculous assumptions in this, but this is the basic mental framework to start working from. But this looks great. Every one of us would do this. This seems like a perfect curve for us. The reality is, of course, this is a change over time, so you might not see this effect immediately. This would be something that you would start employing, and everything progressively gets more productive over time and levels out at our 10-time productivity. Even this, every engineer that you meet would say, yep, we can do this. This sounds great. But this isn't what a lot of people are experiencing. And that's where this challenge really comes in. And I want to show you what they're experiencing, and it might be you, but also why it doesn't matter. So it's very likely your efficiency curve looks more like this. You start using AI immediately, you notice it turns everything into puddles of mess, and you can't figure out how to make it more efficient, and your productivity drops through the floor. You talk to people and say, well, this is terrible, it's making me slower, it's not as good code, I have to do a lot more stuff afterward. But what you're not paying attention to is that 10 times at the end. Now let me talk about this state just for a second, because it looks very much like our duration of 1 time and 10 time is the same. So if we go all the way back to this curve, let's take a look at this one and say, imagine this was a change that we wanted to have a discussion of, and it's $1 billion to do the change. We would say, well, that equation doesn't look real great. For us to do a 10 times productivity to get us to $1 billion of value, it's not worth it to us, unless on the left side is from today until 1 year from now. And on the right side is from 1 year from now until the end of time. Okay, so that's where the cost curve starts coming in. The right side of this curve is forevermore. And so that productivity efficiency is always there. And so when we get to this picture and we say, okay, it levels out at this 10x, then of course we have to do this. And really, I'm here to tell you, all of your competitors are already doing this, and that's really the trick. All small companies are moving to this stuff immediately because they don't have a lot of the historical kind of large application complexity that a lot of us do. And the large complexity is what makes this huge drop-off very obvious. You put it into a big code base, it can't understand that code base. You don't know how to employ it correctly or what tools or techniques to use. So it looks terrible. But over time, it will increase and get far better than any one of us could have been. And then that persists forever. And then reality, what's actually happening with AI, all of our projections show that we haven't plateaued somewhere. We're not at some fixed value that we're trying to get to. This actually is the curve that we're looking at. And this is the actual reason that no matter how much you resist it or feel like it doesn't work for you or is the wrong thing to do, that doesn't matter. It really doesn't matter. If we want to stay in business, if you want to stay productive, if you want to stay employed, whatever question you want to ask, you have to do this. It's coming for you, no matter how complicated it is to employ in the space you're sitting. In this kind of layout, the dip is short and deep, and the curve is permanent. And that's what we're reaching for. Yes, it's going to hurt. Yes, it may take time. You may actually have to tear walls down to get there. But in the end, where it takes us is enormous. And, by the way, required. If we don't go there, our competitors will. If you're a large or kind of medium-large company and you think you have to compete with other large enterprises, that is no longer the case. You are now competing with everybody that can sling this kind of code. They can come for you in a way that they never could before. And if you're a small upstart or someone that's just starting a startup or an idea in your head, you can take on the big boys today. This is your actual opportunity. They cannot get over this curve. You don't have it. That's your value. Attack it. This is your moment. Okay, so if this is a problem and a lot of people have to take it on, how exactly do we do that, especially in a larger system or in a place if you've already put it in and you realized, I don't know, doesn't seem to work. Let me move on and do what I can do with my own little fingers. Let's talk about that a little bit because I have a technique that maybe can reframe the problem for you and help you see a path forward. Okay, we've seen kind of what it might look like. We've seen why we really might have to do it. Now, there are some questions of, okay, how do exactly I move forward when literally what I find is I use it and it gives me garbage back? What am I supposed to do about that? I'm going to give you an analogy here. Okay, imagine you have a big math problem. By the way, congratulations, you're a genius in math. I've bestowed. By the way, congratulations, you're a genius in math. I've bestowed. I'm a genius in talking, and you're a genius in math. I have now bestowed that upon you. Sorry. So, great. You know all math, and I have given you a math problem. Here you go. It's 12 pages, and I say, right now, I need the answer. And you look at me like I'm crazy because it's a 12-page math problem. You now look at this problem as an engineer or a problem solver and say, all right, wait. I can't give the answer immediately. However, I'm pretty sure I can get to the answer. How do you do that? We're all going to do it exactly the same way. We break it down. We find the innermost parentheses and start there. And we start working. And that's what engineers do. We solve the problems. We don't point them out. That's not what we do. We're very, very vital to the people around us, in our companies, the users of our products. We are the lifeblood, and we have to figure out how to solve this problem. And so I'm going to give you a little technique that maybe can reframe the problem for you from this AI, how do I make it work kind of problem set that's in front of you. And I call it problem shaping. So right now, what we typically will do is find a problem, or if possible, find a problem and then go find a tool that fits it. If you found a nut on a bolt somewhere and you're kind of trying to take that nut off, you're going to go find a wrench that fits it and take it off. Makes perfect sense. You might try 3 or 4 wrenches, then you take it off. So that's our analogy for how we typically solve problems. I need to store some stuff in the cloud in a certain way. I'll use this kind of database or NoSQL system because of these properties. Great, that's the right tool for the job. Let me employ that, put the two together. Bob's your uncle. Solution. That's what we do. However, in this case, when what you do is you have one tool and that tool doesn't fit, how do we solve this problem? We don't say that tool can't solve this problem. 12-page math problem. How do you solve it? You have one brain, but you still solve for the problem. You have to shape the problem to the tool, not the tool to the problem. This is a paradigm shift. It's a real shift. It doesn't take long, but it does take a moment, and you will come across it multiple times as you come to moments of saying, okay, apparently AI just can't do whatever I'm trying to make it do. It's bad at it. Okay, I'll do something else, or I'll do it by hand. I'll do it the old way. Break it down. Make it smaller. Do you think AI could take a very small section, one function of that, one line of code of that? Do you think if you gave it all of the context of this tiny little surface area, it could do it? Great. Grow from there. Figure out how much it can do. Can it just do documentation today? Can it just do kind of test cases or CI/CD for you or anything else? There are absolutely places this can already help, and those will get you started on that curve. Now, admittedly, what I will say next is that is by no stretch of the imagination done. You don't then say, oh, you know what AI is good for? It's good for tests. Or it's not good for tests. It's good for this other thing. You don't stop there. That's not your stopping point. That is your starting point. And you see that as your foothold to work your way up the cliff face. And you figure out, where do I go next? Because I have to start breaking down and allowing AI to do more inside of my project on its own so that I can get that scale value. That 10x scale value, we're nowhere near that. We're talking, you might put another 0 or 2 on that. When you really start talking about how much you're going to be able to say, I have a problem or a series of problems. Every one of my bugs, I can get an engineer working on it. If AI can work very efficiently on my software, I can say, here's all of my bugs, spin up an individual engineer for each one of those, go solve them immediately. This is something that most enterprise environments would love to have, is the ability to just completely clear the backlog appropriately by closing the bugs, by fixing them. And the users of those products would love that as well. This is available today. So imagine how to shape the problem to the tool, not the other way around. That's really our new engineering challenge. By the way, hot take here, really, to me, that's the new engineer. And in fact, if any new engineers are out there, by the way, what I call new engineers are people that are entering into this engineering phase or coming from an engineering practice and transitioning into a new mindset of engineering a different way, because you're jettisoning that the old way is the way to do it, and you're adapting to what's out there and trying to learn how to use it. That's a new engineer. So if you thought, oh, I'm not as good at this because there's engineers and then there's me and I'm just playing around, I'm here to tell you, I believe you're the new engineer. This problem shaping, I believe, is the core function and the core ability that we need to craft in people to become new engineers. This is one of the most important aspects, especially as we go through that curve. The change curve is when we really need it. At some point, these tools will get so good that we won't necessarily need to adapt all of our problems to the tools themselves. The tools will probably get better. But for a long time, we will need to say, how do I break this down? How do I take parts of it? I think it's private. How much of it is private? I can put that away, and everything else that I need to touch needs to be broken down so that the system can use it. That's what we need, is people that can do that. To me, that's the most fundamental and most important thing that you can work on today to move into the world of new engineering and through this transition and be valuable. But there are other things. If you haven't started at all and you're just wondering, I don't even know how to do that, let's talk about that for a second. It's easy. Okay, how do you get started? You're just here, you're just cruising around on YouTube and you see a video about the new engineering and how to get involved with it, or how to adapt your old engineering to the new world. Great. That doesn't do me any good because I don't really understand this stuff. I'm just kind of a lurker. All right, I've got an answer for you. I've got real good answers for you, and they're so easy that you're going to be amazed. Here's my actual advice to people that I work with on a daily basis. Number one, if you're not already doing this, this is the first step, and it's frankly the easiest step because you're probably already doing it. Every other day, pick a video, 30 minutes, on AI, go find some people that you trust on YouTube. Now, I know this is a YouTube channel, so I get it. You don't have to trust me. You don't have to watch any more of my stuff. But this is the place to find the current voices that are really exploring. There are some fantastic engineers out there that are trying to share their findings and their truth. All right, and the second thing that I can offer to get you started, if you haven't yet started, and maybe if you're new in the tent and you're still around, I would advise using one of these good code editors. So find one. I would currently advise Codex CLI. It's fantastic if you have an OpenAI account, so you're paying $20 a month to OpenAI. What they offer is brilliant. Claude Code, if you're an Anthropic subscriber, It's brilliant. Cursor can do this. Others can do this as well. So if that's what you have, you're in good hands. Just go find some kind of repo, either an old repo of yours or go find one on the internet, figure out how to download it and have it on your hard drive, and then drop in there and open up the chat window and put it into chat mode. All of these have a chat mode so that you don't have to write code. You're just asking questions, and think to yourself that you're in ChatGPT. At that moment, ask any question you like. What does this code base do? Does it store any information? Does it have state? Do you have to log in to use it? What kind of utilities does it use? How could it be better? Does it have test suites? Anything you want to ask. What is its major color sequence? How does it manage styles? You could put anything into this block and just have a conversation with it and realize this is not a formal environment. It is like ChatGPT, where you start getting used to just asking any random thing about a known context. If the code base is too big or it's not making sense, you can say, what is this folder doing? What's inside of it? And it will stay inside of that folder and look in there. It's brilliant. So one of the things that I advise, if you haven't gotten started yet, use these tools for exploration. It is definitely the best place to start and realize they have a lot more ability than just writing code. Saying, write me a fishbowl application. I need to do that. That sounds kind of interesting. But write me a goldfish fishbowl application. That will work, but that's so limited to what these tools can do. So just use it to explore a little bit, and you'll really start to see the magic very, very quickly. Okay, all right, that was a lot. Thank you for sticking around if you're here at this point. I just wanted to impart the importance. I really think there's a real urgency for all of us to realize this is happening. I know many of you actually already have that message, and you're saying, that's why I'm here. I want to learn more. I want to keep moving forward. Brilliant. Fantastic. You're doing the right thing. I do exactly what you're doing to stay ahead. So keep doing it, and we'll do it together. And really, we'll be the ones pushing it forward as the new engineers. The people that are trying to figure out how to move into this space. If you're here just trying to move into it, I hope this information helped a little bit. Understand, though, this is no longer a decision. We're not trying to figure out if AI is going to be the thing that writes code in the future. That story, believe it or not, is already told. I understand in your environment it may be too complicated to imagine it yet, but it won't be long. You saw that efficiency curve. That thing's coming for all of us. All right, so thanks for coming along for the ride on this one, and I'll see you in the next one.